keragaman, tanpa harus melupakan arti penting ketaatan pada nilai-nilai keislaman. Dapatkah kamu bayangkan mengecap pengalaman global di kampus mondial dengan beragam rekognisi internasional di program studi dengan akreditasi dan sertifikasi dari berbagai negara, seperti Jepang, Korea, Inggris, hingga Amerika. Tempatmu mengeksplorasi ilmu pengetahuan lewat 8 pilihan fakultas dengan 48 program studi yang ditawarkan. Menjadi tempatmu menjemput impian sembari bebas menikmati petualangan kolaborasi dengan ilmuwan dunia. Seraya memperluas wawasan lewat berbagai program kemitraan yang tersebar dalam skala nasional maupun global. Dapatkah kamu bayangkan, kampus swasta paling lestari di Indonesia ini adalah tempatmu menempuh pendidikan tinggi? Kampus unggulan dengan berbagai inovasi berkelanjutan di berbagai bidang. Tempatmu belajar dengan bebas, di tengah rindangnya taman atau dalam nyamannya ruangan. Di luar maupun dalam jaringan, semuanya tak terbatas ruang kelas, tak terhalang jarak dan ruang. Semua disediakan untuk mendukungmu menjadi generasi muda yang aktif dan inovatif dengan keragaman pemikiran yang berbuah menjadi beragam apresiasi. Dapatkah kamu bayangkan jika kampusmu kelak adalah tempat yang mendukungmu sebagai intelektual, tidak hanya cerdas secara akal, namun juga cerdas spiritual, di kampus swasta terbaik dengan akar yang kuat dalam tradisi kebebasan akademik, menjadikanmu berani mengekspresikan diri di tengah-tengah zaman yang penuh dengan kompetisi, untuk berkontribusi akan solusi dari masalah yang dihadapi. Para sivitas akademika serta lebih dari 107.000 alumni pun telah membuktikan diri menjadi insan ulil albab yang mampu mengintegrasikan ilmu pengetahuan dan ajaran Islam dalam menebar kebermanfaatan di bermacam rumpun keilmuan. Dapatkah kamu bayangkan apabila kampusmu adalah salah satu kampus yang berlokasi di kota pendidikan ini, kota Yogyakarta dengan segudang cerita dan budaya yang beraneka ragamnya, dan Universitas Islam Indonesia hadir sebagai kampus Indonesiawi, berdiri berdampingan dengan ilmu pengetahuan, budaya, dan seni yang memberikan warna indah dalam harmoni. Kini berhenti membayangkan dan sudah saatnya bersiap untuk mewujudkan. Siapkah kamu? Karena kami siap untuk menunjukkan jalannya. Dapatkah kamu bayangkan, kampus pionir pendidikan tinggi di Indonesia ini adalah kampusmu di masa depan. Kampus Islami yang terbuka bagi setiap warga negara, tempatmu belajar akan arti indahnya kebersamaan di tengah-tengah keragaman, tanpa harus melupakan arti penting ketaatan pada nilai-nilai keislaman. Dapatkah kamu bayangkan mengecap pengalaman global di kampus mondial dengan beragam rekognisi internasional di program studi dengan akreditasi dan sertifikasi dari berbagai negara, seperti Jepang, Korea, Inggris, hingga Amerika. Tempatmu mengeksplorasi ilmu pengetahuan lewat 8 pilihan fakultas dengan 48 program studi yang ditawarkan. Menjadi tempatmu menjemput impian sembari bebas menikmati petualangan kolaborasi dengan ilmuwan dunia. Seraya memperluas wawasan lewat berbagai program kemitraan yang tersebar dalam skala nasional maupun global. Dapatkah kamu bayangkan, kampus swasta paling lestari di Indonesia ini adalah tempatmu menempuh pendidikan tinggi?
Check, check, check. This is your microphone.
Ada.
Cek.
Tinggal ini aja ya maksudnya. Tes. YouTube. Okay, maybe we can start while waiting the others to be here. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, thank you very much. First, we delivered our gratitude to Professor Yusri Slawi. Is it correct?
Exactly,
Yeah.
yes.
And thank you very much for everyone who joined us today. Welcome to today's international sharing session and maybe research discussion with Professor Yusri Slawi from the Université de Poitiers,
Okay.
France. Today, I am Atina Adika, will be your moderator for this session. And we also have the other guests here. We have Professor Paulo Canas Rodriguez from Federal University of Bahia. Is it correct, Prof. Paulo? Okay. We are happy today that we have a special guest from the Université de Poitiers, France, Professor Yusri Slawi, and let me read his short curriculum vitae. Yeah. His full name is Yusri Slawi. He is a professor at the Université de Poitiers, France. This is rather difficult to pronounce, but I think, I hope that I am correct. Okay, so the research interests of the Professor Yusri includes non-parametric statistics and stochastic algorithm, and then statistics applied to life science, statistical learning of network, and artificial intelligence. And today, the topic of our discussion today is the statistics higher education in France, and Professor Yusri will share about his insight in, especially in the system and curricula. And then if we have more time today, we can also discuss about research and the possibility to collaborate maybe. So without further ado, I think we will have our special meeting today with Professor Yusri. So we have time until 12 a.m. Professor Yusri, the time is yours.
Thank you for the invitation. Thanks to Naomi for presenting this center. and this university, the University of Islamic Indonesia. So it's the first time that I came here, and I hope that's not last time. So I will discuss with you some possibility for PhD in France, and the difference PhD that could be possible. So here I just give some documents in French that I find it in internet, and we traduct a little bit for you the program from a doctoral program in Poitiers. So there are some numbers that they are in France 270 doctoral program. And the difference PhD that we have, it's like co-direction. That means they are just one. The students will have just one degree from France or for another country. For example, I have many students with co-direction from Senegal, Morocco, Tunisia, Lebanon, and they are also co-tutel. Co-tutel, that means the PhD students will have two degrees, one from France, if it's with France, and the second one with the country, for example, Indonesia. But in this possibility, they should have a PhD program also in Indonesia to give him this degree. And we have some hours for formation that the student should flow. In the case of co-tutel or co-direction, if the co-direction is just in French, but it's the co-direction just in the other country, it's possible also. So if it's co-direction, that means the doctoral, when the students make a PhD, will decide about where it will be where the student will defend her or his PhD. But if they are to place their convention to decide in which country and everything about this so this co-tutel, doctorat simple, that means simple is in French. We have each year three doctor PhD. That's our laboratory offer, and we should apply before December. And the different subjects will be available in internet, so you can find all the subject, the three or four, but they are just three. So that means we can apply for 3, 4, 5, and there are selection for just 3. And we receive 2 times that I submit like this subject, and we receive some application for different students around the world there. And we give a short list, like 5, and we select 3. And the first one, if he or she accepts, she will have the PhD. So she's for 3 years. And if there are possibility to have an extension by ATER, what we call ATER is attached. That means 1 year. He can or she can teach like a lecture for just 1 year. That can be conducted for another year. That means, it's special if the students make 5 years. It's 3 or 4. So he or she has the possibility to have 1 more year after defending the PhD. or 2 years if he defend the PhD in just 3 years. And usually the students try to become associate professor. So there is this possibility at the end of the PhD to ask for qualification. And so usually is accepted if there are one article accepted in a good journal. Usually the students have the qualification and can apply for associate professor. So each year we have many possibility around different city in France, and so it's available in a site Operation Post. So this is for students to have an idea about what's happened after the PhD, and there are many possibilities for postdoctoral in France. So co-tutel, this is the, and there are also another PhD with the industrial. It's called CIF. CIFers, that means they are contract between the university and company. And I have 2 students like this. One who just defended PhD last year with the Orange. It's called France Telecom in artificial intelligence, and he now work in London. So it, and there are also the European conjoint. That means from just 2 countries in Europe, but you are not in this case. The different possibilities: co-direction, co-tutel, or with CIFR, but if he is or she is in French. But co-direction, I think co-tutel is interesting if there are a PhD program at the university. So it is possibility to give to 2 countries. The students will have 2 degrees, one from France, another one from Indonesia. And this is the best, I think, for, and the other one is easier maybe for administrative, but it's not very interesting maybe for the students and for also the university, the 2 universities. And the CIFR, maybe many students are interested also by CIFR, and it's as I said, in the 2 cases, co-direction or co-tutel, there are some hours that the student should spend in formation. That's mean maybe it could be just seminar, conference, flow, some course, and maximum 6 years. And there are limits for the number of years, 6. But in all my experience, the students finish or 3 or 4 years. That's not more. It's and this is the limit for 6 years. I didn't see some students take more than 6 years. So I don't know if I go to, if you want to ask me maybe about this, or I go to research, and I don't know if it's.
Isn't there any slides in English?
Yeah, but maybe for a presentation of scientific research presentation in English. But this because just when she told me that they want to know about this, why I think to make traduction for this, but it's there are some words looks like English, but not a lot. It's not easy. But doctorado, you know, doctorado, it's clear. So it's I think it's I see what is written here. This is the doctoral. That means, and I guess yeah, there's different types de doctorat. It was a different type of doctorat and simple doctorat. We shall inverse the words doctorat simple doctorat. Co-direction. That means there are two direct supervisor, director is supervisor of thèse, and lieu is where is the soutenance, the defending PhD. That means in this case, just a decision between the two supervisors where the student will defend her PhD. This is one of the questions, and of course, for co-tutelle, the student should stay 6 months in each country. So it's and for us, we have to just justify that the students will have like 6,000 euro. That means 1,000 euro per month, and for us, this is the thing that it's important. So for the doctoral, in order they sign it, it is one of the conditions. This is for other conditions, it's not so very important, because where it is just the two supervisors that they decide where it will be the student will define the PhD. And I can show you a co-tutelle, like it's because I have for the students. I can show you what is the clause if it's something you interest you. Contrat. Contrat. Co-direction, co-tutelle, for example. Co-tutelle is very for example, this one for with Tunisia. So this is the convention between University of Poitiers and École Supérieure de Sciences. This is the name of the university, another university. So durée, that means duration, the period of preparing the co-tutelle. It's 3 years. Okay, 3 years. Because if it's more, we have to make another document, show the reason of the extension of PhD. Inscription. The inscription we make, for example, the students will make an inscription first year in Indonesia, the second year in Poitiers, the third year in Indonesia, for example. So we specify this is why we indicate here. That means because in this case, the student starts the PhD in Tunisia, first year, and we make the co-tutelle in the end of the first year. So we make she starts in 2022, and the inscription will be in Poitiers the second year, but it is the third in. And okay, so we specify exactly where she will make the difference. If she paid there, how much we pay. So just specify the different. And the period. Here we specify the period, 6 months, 6 months. We specify exactly the period from, but it's not obliged to, if it's just a few days after, later, it's not a good problem. Just if the supervisor say, she is not here and she should be So that's the period we specify. Couverture sociale. This is for social hébergement. That means where she will live, how much the funding, from which projects. If we specify the project, we'll give the funding for the students when she is in Poitiers, because when she is in Tunisia, normally they have funding in Tunisia. It's enough for, because there are differences between France and Tunisia, so we should specify in French. She will prove that she gets this for the second inscription. So usually they ask us to have a proof for that she gets this money. So this is for le présent encore pour moi. Well, they say if there are some problem, so that means she will not be inscribed in second year if but normally everything so she's just the supervisor, director, the supervisor, the name of the supervisor in French, in Tunisia. Donc, that means here they should supervise the work. This is what is written here. The language is in French, but if the students hope to defend the PhD in English or write the manuscript in English, it's possible. Just a few months, they specify it's 1 year before we should send a letter to explain the reason, but normally we do it just 2 months. It was okay because we forget, and the last time we do it, and it was okay. No problem with it because it takes just 3 or 4 weeks, but they specify it should be 1 year before, so we can do it 1 year before it. The formation. So here we specify that it's 45 hours in Poitiers, and we specify formation spécialisée. That means in specific subjects, 18, and methodologic 5 and 7. So we specify the different formation. So the students should have an idea about the different formation that we have and to choose. For example, it's just conference, seminar, course. And if he wants to flow some for language, for example, or for other things, it depends of programmation or something that he's interested by. So just to specify this subject, so we can discuss with the students and see how the thing that he is interested by. The defending soutenance, that means where he defines. Soit unique, that means he's unique, just one in one place, not in two. If he defend in Indonesia, it's enough. So that means here we specify that will be in Tunisia. And for this student, she just send a document that she wants to defend in France. So we just do it. So it's possible. If the supervisor accepts, the two supervisors are agree with this, so it's possible. But this is for a refer for a jury of PhD. That means the two supervisors should be should accept a unique jury. The science of president, that means the president, who is the president, they say that should be obliged to be at least one from each. If there are 8, usually we make 4, 1 reviewer from each country, 1 examiner for each country. Just if the other parts accept, they may be not the same number. But it's usually we try to let it be the same number. We have an obligation that a woman, at least one woman in the jury, and an equilibrium between, this is in French, professor and associate professor. That means you should have at least the half professor of the jury. So this is a specific, that the work of the candidate should be examined by at least 2 reviewers, that they have the habilitation of flow research, because this is specific in French. We have a doctorate, PhD, and habilitation. So few years, or it depends of the research. The research write like another PhD, but it's the name is habilitation of flow research. And this is the different step of PhD. So this is the different step. 8 weeks before the defending, the supervisor should send a list of jury to the l'école doctorale, which we call l'école doctorale, which is a doctoral program. And 6 weeks before, the candidate, the PhD student, should send a manuscript to all the members of jury, and the reviewer should send the reports 2 weeks before defending. And then, if it's okay, well, we can, everything is, this is what's writing here, and the members should be between 4, at least 4 and 8 maximum member, and they have at least one woman. And here we specify exactly who pay. For example, when you come to Poitiers, usually in Poitiers we pay for hotel, for transports in France. This is what is writing here, and just the one buy tickets, plane tickets to come to the other country. This is why, for example, if the defend in France, if it's with Indonesian pay the plane, but the others thinks it's France who pay train from inside France and hotel inside, and eating and everything in French. In French who pay. This is what we say here. And in the opposite, the French pay the plane if they go outside, and the rest is that is usually what we do. It's in the which is writing. And the deliverance of the degree or diploma, what we call diploma in French. So this is first. If it's in French, we give the degree, French degree, and after automatically they get the other degree without defending in the country, in Tunisia, for example. And in the opposite, the same. If she defend last year, she defends in Tunisia, automatically she gets the PhD in French. We had just to sign the everything after defending. This is for protection, for production of PhD. The 2 parts are proprietor of the results that they obtain in the framework of the PhD, and the results after defending. So this is the clause that we make in if they have brevet or something like that. So it's just I think they did the last one after the signature of doctoral, two supervisor, the director of laboratory and the commission, the program, doctoral program, and the director of UFR, if they are UFR, president of the university. And so this is an example of one of my last, well, not the last one, but one of, so just to give you an idea about so it's, so what I say, I have all documents in French. I didn't think to, but it's not very complicated to make traduction of this. If there are this, we can write it in English. For us in France, there are no problem between French or English, because we know that all the articles are in English, and the student, there are many who will work not in French, and this is one of the reasons, because we can see the origin of they don't have French, they don't speak French, and he will work or she will work outside France. That is one of the reasons that we use usually. And last year I have French. He's from France, Leo Grill. It's from France, and he wants to defend in English because he planned to go to London to work there. And now he is in London. He work office, and the PhD is written in English, and he defends the PhD in English, so it's not a problem. And if there are possible, we can make also the co-tutel in English, because everyone there understand English. So not. So this is an example. After, if you have question, I can try to go to another document if I have, and or tell you exactly what we have in France.
Okay. First, welcome Professor Didier Rusadi. He's professor from Gajah Mada University. Thank you very much for joining us here today. Okay. Thank you, Professor Yusri, for the explanation about the doctorate program in France. And maybe anyone here have question?
Maybe you can also explain a little bit about the undergraduate system. Maybe
Graduate system.
How about the undergraduate?
Graduate.
Like magister program maybe.
Master. Master. We have below, but they are baccalaureate, I think, bachelor that you call. Yes, and after they are 2 years, usually in mathematics, we have in the third year, there are 3 years. The third year, the student can choose the specialty of statistics or applied statistics. We have this possibility in Poitiers. And after, automatically, we have a master statistics données de vivant. That means statistics and applied to live data. Okay, and there are some unity of with the biologists. Then flow some two courses in biology, but not the complicated one. It's the one that we use statistics a little bit with the biologist. So he flow this two unity, the first year of master and also the second year. And the first year they are training for between 2 weeks to 4 months. The students should have, and but and the second year, the students have two possibilities to have an alternance between company and university. So we have like, I can show you, we have internet, I can show you. Okay, connected. That is mine. You see, I have nothing. Just tomorrow I have sittings, but for the students, I will show you for the students. D'étudiants, SFA, second year, in mathematics, and okay, in mathematics we have MFA, it means fundamental mathematics, fundamental, and this is for STDV, for science. And here this week, this is the program. So in the university, also this week also, and after they go to the company 1 week this week. It depends of the students. If they find a company in which they make training during all the year, and is alternance, that means 2 or 3 weeks at the university, 2 or 3 weeks. If they don't find, we have to find them a subject in which they should work for 6 months, and they have an obligation to find training for the 6 other months. If they don't find, it's there no degree for them. So this is an obligation for the second year. First year is not an obligation. If they don't find, we can find subjects for them, and it's okay, can pass if they have. So this week, they have just 1 week, but after they will have more. This is vacation, 1 week. Here, training at the university, at the company. Here also it's university, training, also training, company, university, December, no, vacation 2 weeks, and now exam. This is an exam.
So you also have a kind of final project for the student, right?
Yes.
The last one is final project.
The last one is exam.
Final exam.
Exam for the whole the first semester. It depends of each subject, because they are with 2 exams and therefore just 1 exam. 2 exam, yes.
How many credits that you have?
Credits that for each subject there are 6, maybe divided in 2, 3, and we have for 18, I think it's like 90 or something. 90 for all year.
So between 2 years experience. 2 years?
2 years.
2 years.
No, 90 each year. First 90 each year, yeah. I can give exactly, because and the training for the second year cost mini credit, I think 24 or some 30. I am not. I can give you exactly, but it's cost lots for the second semester. It's more than the half of. It's the like I think it's more than 30, because before it was 25, we changed it to 30, and there are discussions to be the half of the year. 45. I think 45 from last year, it was 35.
5 times 4, maybe?
Huh?
145.
what? The project's first year cost just 15 first year.
15 in the
First year. But the second year is 45 per year. Yeah, for 1 year, yeah, for so 120 for course and 60 for project. No, it's 60 for projects. It's 14 years.
90 plus 30. 15 per semester in the first year. Yeah, 15 per semester in the first year.
First year, just 15 at the end of the year. That's all, because it's in the first year, 15, second 45. That means 60 for project and 120 for subjects for.
Not much different.
For me.
System also.
So,
Yeah, but we have some additional
Yeah.
costs which coming from the government. Everybody has to pay.
Yeah.
It's not
no,
related to the
because-
subject concept, but we have to take it.
it's
It's an obligation, yeah, from the government.
we have some optional for example, biology, something like that. But all of our subjects is an obligation for our students. The statistics non-parametric statistics, série temporelle, temporal series, time series. So there are some subjects are obliged for all the students. And this is the second, it's more time they spend, or more time at the university and the office. And you see from January, for example, here, you can see all they are noting here. But I think because here is obliged, even if they didn't find an alternance, he should or she should to have training. So this is why we don't make nothing from here, because it's here the course is finished, everything is finished at the university. We should be outside the university, and we should not propose subjects for him or for her for inside the laboratory. That's possibility just for the first year. Yeah, yes, it's possible. Of course.
Maybe you can explain to us how is the procedure to make a collaboration between maybe university in Indonesia.
Yes, I do it many times. Co-supervision with Liban, with Moncton in Canada for students. That is okay. So this is just two supervisors. We decide about subjects. Usually we have funding, but if there are many other funding, it's because important for the students, and it is important for that they accept administratively the subjects if they are funded. So for me, I have mentoring with different company in France, for example, with CHU. CHU is a hospital of Poitiers. Each year there are 1 or 2 subjects they propose and they are funded. With some federation, I get every year I depose projects, and they give me some funding. I propose some subjects, sometimes with the other country, sometimes by myself, and sometimes we have, for example, with Canada, we submit projects and we have funding, and we ask for we make the announce in internet, and we have some students, they apply, and we choose one of them. And otherwise, I have proper funding industrial with the company, and it's not an obligation to have to propose subjects in with exactly in subjects of what I work with the company is my proper funding. So I for example, with this year, the object the objective was to write package in R, and it was a little bit hard for students of our formation, so it was an informatician from an informatic that so he finished and they just submit the package. So this is different funding that we can have, and the student will be more interested, and also the responsible of the formation is more interested by some subjects who they are funding, because we have an obligation to pay the students if the training is more than 4 weeks. And all my the one that I choose it for 1 week, and we pay them. I mean, we have contract for them, and so we just the subjects, the funding, and it's finished. This is the.
I think because we have master program here, so is it possible to make yeah, maybe we might try to make a collaboration like juggling three to the master program.
Yeah, I think it's.
Is it possible to is that we just need to make a proposal to the university?
Yes, I think
Or
it's.
we have to have one in memorandum of understanding between universities, or just
Yes.
propose to the professor?
I think it's good. That's a good idea. It could be interesting, because I can tell you one thing, because I have 2 affiliation. So from the 1st January, I will move to Canada, but I start to have the affiliation of Poitiers. So it's possible to make it with Poitiers, but it's also possible to make it with Canada. We talk with the other person in Canada, and they are interested, because the same proposition was told to me from Tunisia when I was recently. So this is possible. So we can discuss. We can, if you want more Canada, it's possible. If you want more France, it's possible, because I will get the 2 affiliations, so we can work sometimes in France, but also in Canada. And, so this is possible. And my colleague in Canada, we just talked yesterday and about this possibility, because I think it could be interesting.
Any other question from the others? Paul, do you have any question? Okay. The others? Any other questions? No, Prof. Deji? Okay, because I think maybe regarding the curriculum, there is no other question, so maybe we can just discuss about something else. You can share about what are you working on now?
Okay.
Yeah.
I will see Dr. Alors, maybe this is. It's not during the. Okay. Alors, Ctrl-L. You can make it in screen. Maybe I can use. I have one. I should make. Let's say have one if. You have okay. So we can present to you one of subjects. I think there are two subjects here because present to you functional data in non-parametric statistics, and with a comparison between by one of statistic and parametric statistical block model classification in this parts, which is unsupervised classification. So I will start with call about stochastic approximation algorithm, and after functional non-parametric statistics, and I present some estimator in the for prediction, other one for supervised classification, and then unsupervised classification with application to psychological data. And here I present another method, and we compare these two methods, and I give some perspective, and I end by giving some reference. So not in the framework of non-parametric statistics, this part is just non-parametric statistics and stochastic approximation algorithm. So here I give the general form of stochastic algorithm that I consider. So it's written as follows. You can see it, gamma de n, what we call the step size of the algorithm. Theta n, the seconds to be recursively estimated. We see this is a recursive relation here. Wn, seconds of a random variable representing the online observation. So this Wn change in each estimator we want, if we are interested by density, regression, quantile, this Wn will be changed according to what we want to predict. Phi de n, the function which defined how the parameter theta is updated as function of new observation. Okay. And n is a small perturbation of the algorithm. So here I said that the behavior of this estimator is studied by many authors. I list some of, and there are many applications like in system identification, adaptive control, and others applications. That's the first algorithm considered one analyzed by Kushner, Jung, and Rupert, and is written by this relation, which is much more easiest than the first one, where mu de n is a random variable converged to 0 box almost surely, and phi is a measurable unknown function. They show that 2 is included the Robin-Morrow algorithm, Kiefer-Wolfowitz, the 2 very known algorithm. That's the search of 0 of function phi. And usually we use this condition. It means the expectation of W de n that I defined before depends on the data. Conditionally of all what we observed before is equal to 0. Okay? And this is one of the conditions that we will use to construct this W de n. And after phi de n. Under standard condition, the flow show that the n converge almost surely to parameter of interest. And so the motivation is to construct a recursive estimator. So the recursive estimator can be updated from their immediate past and the new observation. And the updates can be computed instantly and does not require extensive storage of data. So it's interesting to use this kind of algorithm in the framework of what we call big data. So here I present for functional non-parametric statistic, but I use it for other fixed dimension before, or multidimensional data, and here for functional data, that means the dimension is infinite. Okay, this is the difference. So I give here just an introduction of functional data and the difference between multivariate and functional data. I think that's the first possibility. If we have this curve, it's to consider xe as a realization of random vector multivariate, which is multivariate case. Possible problem is that they can have different grid, and the observation of the same continuous phenomena model should involve all correlation. Other problem, if the number of observation is slower, or the number of p is bigger than the number of observation. It's one of the problem of multivariate statistics. So the second possibility is to consider xe as an realization of a random variable, and which take value in functional space. That's we consider here. That means we consider f process, stochastic process, and we consider what we call functional data analysis. More exactly, I give here the definition. We can a random variable is called functional variable is take values is an infinite space. An observation of x is called functional data. Functional data sets is observation of n variable. We consider identically distributed, but we can also consider their dependence, and that's what I consider in many other words. The family of observation, we can take H is Hilbert space, and we can consider theta in R. We can also R or RP. So here I make is essentially impossible to measure x theta for each theta, but it's possible to consider a smooth discretization of theta in order to consider that the behavior is close to the one of x. For example, this problematic, given a spectrometric curve, we can estimate the percentage of fatness of the piece of meat. We know the percentage of fatness for some y, and which was obtained for reliable chemical analysis, but more expensive in time and less economic if they are a relation. That's a spectrometric methods. That means if we have a relation, we can have this information easily based on the few one that we have measured. So that means the problem of regression that we can solve. I give here some functional data. For example, time series concern the mode sea surface temperature. I have another example from US monthly electric consumption by the residual and commercial sector. Another example of spectrometry curve. Okay. This is very known in functional data. And the last one, which is new from electroencephalography. Okay. This is a psychological data, and exactly what it's concerned by. So you are sitting in front of screen, and you should write the name of the picture that you see the most correctly possible and the most fastly possible. And we have 128 electrodes in the screen. Okay, so we have 128 trajectory here. And one of the interest, I will explain to you later, it's to know which electrode is associated to a step of the brain. Okay, because when we see a picture there, the brain make 4 steps. The first one, you just see the picture, okay? The second step, to know what is concerned. And the third step, to know the words, and after to the planification of how you can write what you see, okay? So there are 4 steps. And we want to make a relation between this 4th step and the region of the brain which is associated. Okay? When we see, we know this is just these parts of the brain which work. Okay? And after different steps, different parts of the brain. And this one of the things is interesting because if we know in which electrodes works, maybe for a person who have some problem, we can detect the area or the region exactly where there are problem. Yes.
In this example, it is one line or one function for each event.
For each electrode. Here we have just one patient, one person, okay? And this is for the time, because just this for this example is just 250 milliseconds, okay? And but if it's we want to make for a long time, for many picture and see exactly, there are some for more, and say mini picture. Okay, this is just one picture for one person, normal person. Okay.
Do you assume that this is coming from the one process?
Yeah, one person, yes. 128 electrodes we can see here, because in the beginning all they are in zero. So 128 electrodes in the brain. Okay. But different because the electrode is different, because the brain change, because the brain, when you see the picture, there are many steps, 4 steps. The first one, when you see it finish, this part, this electrode will not work, because you see, you can close your eyes, not because you understand what happens. But the second step is you see the picture. So what is the name of this picture? And after, you will think about how you can write this word. And the last is the association, because we see it is a screen. How you write screen, you will think about how we write it. That will make time, and the many person will not find, and we see, it's pronounced you just window, door, something. It's very easy. That's all they can find the word. And take time for, and also it's for origin of the person studied, because we will not ask someone with the French, or he's speaking English in Indonesia. Okay, so it depends of this. This is my colleague. This is of my colleague psychologue, in psychology, and this is his own experience, and my experience was similar. We can make both, and the mine was almost similar. So I show you 4 examples of functional data, and the question that we ask, we observe sample of terrain curve. The curve can be classified into several categories. It means classification. Are we interested by classification, or are we interested to predict from the curve another characteristic? For example, spectrometric curve, we are interested by the make a relation between the fatness and the spectrometric, that means a regression. To make a regression, we have interested by a response or variable of interest, explained by another characteristic. So we start by prediction. In prediction, I give here the model that you know, everyone you know. We can consider just sample 1, make hypothesis in the variance. The residual is centered. There are many applications. And we about our example in the spectrometric. Y is the percentage of fatness X is a spectrometric curve and which depends of the wavelength. Okay, and our goal here is to construct a recursive estimator of the operator R by using stochastic approximation approach. Okay. So in the literature, to estimate the regression function, we consider this square error expectation of the error squared, which give this estimator, which is expectation of y conditionally of the curve. In the literature, there are non-parametric estimator of the regression developed in 2002. It's about 22 years, which is an adaptation of Nadare-Watson that you know is 60 years ago, which is writing as follows. Amiri, Kram and Tiamon 2014, 10 years ago, considering adaptation of Amiri 2. And they write this recursive estimator. This is a recursive estimator where f is the cumulative distribution function of the random variable. So I developed recently, 4 years ago, published in Statistica Sinica, an adaptation of work that I developed in fixed dimension or multivariate statistics. This estimator, okay, where gamma de n is the step of the algorithm, h is the bandwidth. That's, you know, if you use the kernel estimator. And P de n is the product 1 minus gamma de, where gamma is the step size. And these are written as follows. Okay, it's maybe a little complicated than this one, but I think I have mentioned that this one is a special case of this one. Okay, with fixed, with a chosen step size, we can find this one. I think I didn't put it here. Here I make that is possible to consider also write this estimator as follows: as a ratio of 2 recursive estimator. The estimator that I just presented before is. This is, we can write it as a ratio of 2 recursive. We can see it's recursive. At the end can be explained recursively. F the n can be written recursively. But R the n is not recursive. We have all the advantage of recursive, but it's not exactly recursive. It's a ratio of 2 recursive estimator. This is this first one, this estimator. They are a recursive estimator. They developed 2 years ago. Can write it as flow. R the n, which is our interest, can be written recursively. And here we have f the n, the density, which can be written also recursively. Okay. So I present you just the estimators. Now, if we suppose that we have some outliers, if we use the last criterion, which is the expectation of the square error, this will be not a good idea because we will give the same ponderation of all the observation, which will be a mistake because we have some outliers. Okay, so we can we consider which we call the relative regression estimator, which is written as follows. And by minimizing this quantity, we come to this regression function, which is a ratio of these two quantity. Expectation y minus 1, y minus 2. Okay, and this we can propose an estimator of this quantity. Okay, I'm not the first one that I consider this problem. There are among Cotter and in 2016, which considered this estimator, which is another adaptation of Nadari-Watson. And recently, in 2019, I consider this estimator. You see the difference between the last one, just the y minus 1 and y minus 2 here. Okay, and of course we can develop the asymptotic theory. I think I give just few information here of about the construction, how we construct this estimator to come off to propose this estimator. So we want to approximate the algorithm. This consists to looking for a zero function of this function. And there are two steps. We fix G0 in R, and for n bigger than 1, we consider G de n equal to minus 1 gamma de n. The observation, that means what we see, that the expectation of this observation conditionally of the path equal to 0. This is why we consider this relation, because we know that the expectation of this quantity will equal to we go to 0, because equal exactly to this quantity plus a quantity which goes to 0 when n is big. Okay, n goes to 0. So we can estimate this quantity by this part, because we know that the expectation of this quantity equal to this plus quantity goes to 0 when n goes to 0. So we replace this here, we come to this, gets this quantity. Okay.
Your previous slide, when the ratio for the conditional expectation between y
Yeah.
power minus 1 and
Yeah.
y power minus 1.
Yes.
What's the definition for the y power minus 1 and y power minus 2?
But it's the integral agreg y minus 1, the joint density xy dy. It's just and it's in the space where we are working, because here if it's Hilbert, it depends on the space, but it's the integral of y is 1.
There is no interpretation for maybe if we have a real case and then we have y as the dependent variable, is it true?
Dependence.
Dependence variable.
Mhm.
The y here is
Yeah.
dependent variable.
Y is the response of our model,
The response of
the response of the model. Of the model,
let's
it
say
is
that
the
we
same.
have a response model y, and then what the interpretation of y power minus 1 and y power minus 2.
I,
I didn't get it.
so this is y.
Yeah.
Okay, this is the regression model. You know that for the first thing is okay. We come to y because they have problem. For the second, I see when y is positive, strictly positive, or the presence of outlier. So that means, and we come to here, and so I will give an application. Maybe it will be, but that means when we consider this, automatically it's easy to check it. We show that R will be equal. This is the quantity that minimize this quantity. Yes, minimization, direct minimization. It's the same, because for the first one, this one is directly, we know, it's come from the minimization, because what we can see the expectation of y second conditionally of x 1 2 theta x expectation y. So we divide by in function of R, we come directly to this quantity. It's known. This is in parametric or non-parametric statistics. We know it is the best and best predictor. Is this expectation, and the second one is in 2, 3 line. We find directly we derive, we multiply and we write it directly. We obtain this in function as the optimization of this. And this is why they proposed first in 2016 this estimator, because when I think about this problem, because in the real life we can have some the presence of outlier, and it's a mistake we can show in a small application that I consider in this paper published in Journal of Multivariate Analysis. It's we can find the difference if we correct by considering this, if we consider the classical one. And when I see the problem, I see that they are before me. 2 years ago, I have this, consider this estimator, and I propose this one based on the algorithm stochastic. So this is the consider. Here I give, here it's very important, because in practice, but also in theory, in what is the interest to use the recursive estimator? Because it's interesting to have a recursive estimator updated when just we receive one data than one data. But it's more interesting if we have to consider different subsets of data, or one, for example, coming from Indonesia, another one from the USA, from the United States, and Russia, etc. If we have this, it is more interesting to use our estimator separately, calculate in each place, rather than to have all the data. Maybe it's not possible for that they send you the data. You told them, just give me some information. They will give it to you, but if you ask them to give you the data, it will be for maybe impossible for them. So this is what I want to make here, because I make that my estimator, I can write it as a combination between many estimator. I show the case just of two. For example, I have one from Indonesia, one on French. And I use my estimator developed in France, other one of, and they ask me, what about all the data? If I can give the information here, I say, the estimator is a combination of these estimators, two estimators. That means locally, we have to work locally for different parameters. For the bandwidth, which play an important role in non-parametric estimation, the bandwidth, the step size of the algorithm. Even if we have some problem locally, missing of data, some sort of data is locally. Okay, it depends of each, and this problem I consider it in many cases in some sort of data, and it's very important because we can treat many problems by this development. And when the thing that we consider for two subsets of data, we can consider for 3, 4, 5 the same. It's just we change the equation. And after here, I gave some theory just to have, because we are interested by development, convergence, etc. So this is classical hypothesis that we consider. Well, here it's important because I consider usually this class called class of regular variance sequence, in which belong my bandwidth, the step size, and the importance of this is just to have a relation between the bandwidth in n and n minus 1. This means a recursive relation. In order when I get my expectation variance, I will be interested by just to determine one step size, not all the step size. Okay. You can understand more here because we use this, which we call technical lemma, which will give us the expectation and maximization. And we can see that in my expectation, I will have just h to n, h. And here just gamma n divided by f, h to n, not h1, h2, hn. And it will be easier here to estimate or to consider a bandwidth that minimizes the mean integrate square error or mean square error. then to estimate, looking for all the step size, all the bandwidth. So this is the expectation variance in different domain because they change, and we can obtain the theorem of limit central here, and the band of confidence. So this is a thing that we are interested. Here we can propose an estimator for different quantity. So it's to construct our interval of confidence. And one of the important thing if in non-parametric estimation is to estimate, to propose the bandwidth. The bandwidth is the n. So here we propose a bootstrap wild bootstrap, okay, rather than plugin or cross validation. This is so. This is the we draw epsilon according to this distribution, and then we consider y once L because they are 1 and 2 equal to this quantity, and we determine this estimator, and H star will be the minimization of this difference between this one and the one with G. And we are interested also by some theory. We developed some data-driven bandwidth selection. So what about the BA, the difference? And here this result is very interesting because we know that in the literature then that the G de n, G should be larger than H de n. And here we prove it theoretically. And it was very interesting results because it was using in practice before that G should be bigger than H de n, H, and use it in practice because in practice give good results, but we can show it here theoretically. In order that this B will be close each other, we had to consider all of these assumptions goes to 0. Okay? One of these assumptions here, that G de n will be higher than H de n. Okay? So that means here to make a relation between practice and theory. Okay? It works, that's good that it works good in practice, but why? What is the reason? Is that we give here one of the reasons. So is this one of the results that's interested, that means make theory or a link between theory and practice. We are interested by the normal, we have the same limits here between the law of this distribution, bootstrap distribution, that means using the data-driven bandwidth selection based on the wild bootstrap. And what about the classical one? We saw it's almost surely equal to 0 by using distribution or distance of Kolmogorov. Here I give you just an application, schemographical application, in which there are some data. We can see that aberrant data here and here. We show this is a package existing in R. It's not me who developed this package, but I use it just to show the aberrant data. Okay, and we see here if we don't consider the proposed estimator, we can see by considering the estimation of this overall this aberrant estimator data, we can see it's far from this. And here we correct this problem by considering our estimator. So it's interesting to consider the estimator based on the relative estimation error rather than the mean square error. So for classification, I will just present here the estimator. You see the construction. It's by stochastic approximation algorithm is here we are interested by the probability of belonging of class. Okay, and they are one of variety of you work in 2003 developed this estimator. I proposed in computational statistics in 2021 this estimator. A bit complicates, but theoretically and also application give good results. I show just application parts. I will not give the, and we are interested here by to measure the performance of this two estimator by considering the mean prediction error, which is the number of time that we make mistake. You see, that's his difference. This is the group. G is for group. So the number of time that we don't find the good group. And we calculate this, the average mean prediction error, that means number of time simulated. We consider here 500 of this. We consider a quadratic kernel given here. I consider here like a mixture of three groups. For the first one, mixture of these two G1, G2 function. The second one is mixture of G1 and G3, and the third one G2 and G3. Okay, I give you just G1 or G2 to see the class one, first class. You can see that we can make, for if we use just our eyes, it's class. We can make a confusion between some curves. It can be, for example, this one. Maybe it's not. And we consider some learning class for each class, class 1, class 2, and testing class for different class 1, 2, 3. And when I make 1, 2, that means we receive first data, and for 2 we receive another data. Okay, to trace it separately. And here the number of simulation replication, the norm 2, because also for the norm play a role. I just take L2 in this because it's not work to choose of the norm. Okay. I choose quadratic kernel also for norm kernel. It's another story how to choose of kernel. And I can give you a comparison between a recursive and non-recursive. You can see that the recursive one, also the non-recursive, give quite similar in average. So 89, 98, 78, exactly, approximately the same mean. But the running time using the recursive kernel estimator is 368 seconds, the auto workstation. And the running time using the non-recursive one, it's 3 times more. Okay, you see it's 3 times more using the non-recursive than here. If we consider more complicated data, for example, coming from phoneme, this is explication, SH, SHE, DCL, dark, and they are a huge number, larger than the one that I considered before. 4,509, and after many replication, and here that we can make confusion, for example, between AA and AO for some curve. Others maybe it's clear. And this is just a graphic for 50 log per logram. And here I consider 5 class, and we receive 2 times, first time and second time, just to illustrate how many time we can spend if we use recursive and non-recursive. And the same norm, the same kernel, the same number of bootstrap replication. And you can see that the non-recursive give better results. But if we can see the difference, it's approximately 15%, and here is the 15%, 0.5. But the time, here the time you can see. The recursive one, about 35 minutes, but the non-recursive one, more than 40 hours. Okay, just for this sample example. So you see for the interest of using recursive estimator. So we lose little, but not a lot, with 15% of error here, or 15.5 here. Okay, but the difference is so important in terms of time. Here for unsupervised classification, and we can evaluate an estimator for this what we call small bold probability, which is written as flow based on h, which is calculated flow in this way. So we can give you more if we have time, and we are interested by the mode of the flow in pseudo estimator. And the number of group will be determined by the number G of the peak. So I mean, we see the peak, and it's in non-parametric case, this is what we do, and splitting the probability points by the partition sample is here, and we look the local minimal probability density H. And we are interested by some theory of this pseudo density estimator, and the mode is the maximum of H, which can be written as the maximum of this quantity. This is some theory. I will not show you exactly, but I can give you some information about this assumptions, what I developed here, and we give some theory about this pseudo estimator, and then about the proposed estimator of the mode. Okay. And before that is what I explained to you, the experience with in psychology, EEG data. That is what I specify participants in front of a screen, graphical relator, an image presented to the participant should write as quick as possible, as correct as possible. And we are interested in period of interest, connective process, involve written production. So the first movement, this is what I see, the 4-stage visual perception, objects presented, access to the world, and planning the gestual necessary of written. And this is different region of the self. And it is 128 electrode. This participant is like that. It's a cask, and I explained during each activity, the brain, the neuron of the involved parts will start working together to produce the ECD, equivalent current dipole, which is measurable at the surface of the scale, which represent the electrical activity recorded in electroencephalography. And this is the figure that I showed at the beginning. And this is a spatial view of 128 electrode. And the question which is to find the electrode which works at each step. Okay. So we can use what we call the SBM that I will present, but before that there are some, I make the objective is to determine the brain access area electrode involved the different stage of the activity during the period initialization latency. And it is known for the visual activity that appear during a temporal windows that begin at 75 milliseconds and end at 150 milliseconds. It's equivalent to 40 time frame and end at 80 time frame. This information is important because it's known in the literature. That means is our algorithm don't find this is they have a mistake. Okay. From the EEG analysis, the positive activity appear and it became positive at 52 time frame. This information present in the literature before that we did this work. So we take care about this to see if we find this or not. So that's what we see. The absence of this activity may be an indicator of the appropriateness of the approach being considered. So our data, we have a matrix of electrode by time, we have dimension 128 multiplied by 285 time. So for each time step, we consider the constituted network as flow network associated with it. What I really want to say here, we have our matrix and we have two information. The relation between electrode, if it activates or not activates, and also the intensity electric of each electrode. So we have two information, and we have a network. And we want, so if we use the classical one existed in the literature, there you see that if there are link between two electrodes or not, okay? But it's important to have this ponderation between two electrodes, okay? That's mean this ponderation, and also because we have here two information, okay? So this is the new in this work is we make a John Loy in each edge. One, we give us based on the information activates or deactivates, on the other the intensity. Okay, and we modelize this by John density between the first one is just Bernoulli, the second one is just normal. So stochastic block model. Stochastic model make an information. It's easy to show if they are pen or they are there. Oh, I see. Huh? I can write there. Oh, thank you. Okay. So we have our matrix like this. It's there. Here.
Not this one.
Huh?
This one.
Here, but it's not so. It's okay. Like this. Okay, you see it. Okay.
Sorry,
This,
because it's new.
but here it's better. Okay. So we have our matrix. I didn't realize. It's okay. So we have our matrix. In the SBM, stochastic block model, they make just this small that we can understand easily. For example, we see that we have three groups. I make three groups. The probability of connection between this two electrodes is the same between this one and this one. The same probability in this group. And it's the same inside this group. This one, and the same probability here. Okay? But it differs from this probability. Okay? And the same for this group, inside the block, the same probability of connection. And is the same probability of connection between this and this, on this and this. Okay? Which is different inside and the same. Here is the same, here is the same between this electron is the same. So this is the stochastic block model. Make is inside the block with the same probability of connection, and outside between two blocks is the same. If it's the same group, any one of these electrons have the same probability of connection. So this is the assumption we made, and after it's so it's what that's what's written here, and so the network is supposed to be managed as flows, observed node. We consider graph. So each electrode is associated to a vector. to associate. This is so just to give you here the latent variable, because the latent variable which they contain the number of class. Like when you did the expectation maximization algorithm, you see that the latent variable is the one who contains the information or the number of group. It's like, because it's mixture model, it's kind of mixture model for data network. Okay, so it's the same thing. So the observed edge are conditionally dependent on the latent variable. Here we have these two information. The first one, it's flow Bernoulli with parameter probability of connection, and the weight vector are conditionally interdependent, and flow a Gaussian distribution. That's we consider, okay? And we are interested by estimation of this parameter, probability on belonging to a class, the parameter of the Gaussian, the parameter, or the parameter, the frequency, the frequency of a group, okay? And so we try by writing the log likelihood, which is complicated because it's like a marginal of the joint density between the observed variable and the latent variable, and this marginal is very complicated. This is why we try the expectation maximization algorithm. So which is, as you know, it is is indirect optimization of the likelihood by direct optimization of the expectation of the log likelihood of the complete data. Okay, so the expectation parts, we calculate this expectation, conditional expectation of the log likelihood of the complete data, which is interactable because of the conditional dependence of the latent variable and observed variable, and maximization with respect to actualize the data. So to overcome this problem, we consider the variational approach, which consists on the approximation of this probability, the conditional probability, okay, by a more manipulable distribution. So we write this log likelihood as in function of the divergence of Kullback-Leibler between the interactable distribution and this probability, this probability of condition and this more manipulable distribution. Okay, and we will be interested by this quantity, which is called the Born inferior. Okay, or lower band. So lower band is written as difference between this quantity, and it was shown in Dudan and Cotta in 2008. Variational maximise we assume that R is a product of multinomial distribution with parameter 2, so we can develop this lower bound, and we can maximize this lower band with respect of 2 of the parameter of multinomial, and we find the flowing fixed point relation, and after with respect to the other parameters, and we find the other parameters. And the two that you have the number of class, we consider ICL for integrated classification likelihood, which is written as flows, and we maximize this quantity to have the number of class. So we come back to our data, and we find 4 class. Okay, and we can see the trajectory or the mean of the electoral values. We observe that for the P100, the component, it's become positive at exactly 552 time frame and attain the maximum before 150, as it's shown in the literature, which prove that our algorithm give a good results. What about the classical one? If we use the developed package in R, which proposed, we find just 2 class, and the absence of this information of P100. Here, if we consider a non-parametric model that I proposed before, we find also 4 classes. We can check for P100, we can find it also. And we compare the two approaches. We see there is some difference. This means some electrode shows here, there are some, but it's more than 80% is similar. Here I give you a view of dynamic vision, because here we can see that they are different. Just in this small example, we can see that there are some electrodes change the class, but that means in the perspective we have to take some process to have for longer experience, and we'll be interested by medical research. And this is what I make in perspective extend propose to classify to more developed model with dynamic using dynamic block, stochastic block model, classification of physiochemical parameter for a river, for example. We did this work, so there are some perspective that we consider that I developed here. For example, for dynamic, we can consider some process like Hooke's exponential process. Let's change. It's possible to consider also the overlapping problem or the multiplex. That means in edge we have many information, or for example, or they are overlapping, because here in what I show in Blackboard, it's we separate exactly. There is no possibility that electrons belong to two class. Okay, but this information can be included also in biology. We can know that some gene is participate to works for can belong to class. So this is one can be also perspective. Also, I make here for the first part some spatial temporal data, some sort of functional, missing functional classification, large moderation. It's more theoretical, it's possible. It's also, we consider just T in air, but it's also possible to consider image. Other computation, I consider just kernel estimator, but it's possible to consider Bernstein or polynomial Chebyshev, because we know near of the edge we can have some problem by using kernel. So it's possible. That's what I did for multidimensional case, but not in functional data. Well, I give here some reference. Amélie, Sophie Dabo, Ferrati. I give you also some paper, the first in multidimensional case, and then for functional data in multivariate analysis, stochastic. Here in with the dependence, with a strong mixing function, statistical inference stochastic process. Here in computational statistics, this is for 2-time scale. This means, and another reference for the one for stochastic block model. This one which computer statistical simulation computation, and for Latouche and others. So it's I think it's I can stop here, because after I show Bayesian approach and other I think it's
okay.
enough.
Thank you very much, Professor Yusri. We still have 6 minutes left. Any question, everyone?
Yes.
Depending on the prediction, why don't we simply apply standard, let's say, time series analysis to do the prediction? Why we have to consider this functional data?
Functional data, it's, that's what I want to say. It's for n dimension with not in dimensional fixed dimension. It's for a large dimension. That means we have, usually we use it when we have many, we observe trajectory. You see, for example, we have like EEG data is just for small, for 250 time frame. We have, that means lot of observation because we see all the trajectory. We are interested by all of the trajectory. And that is the reason we use for, you consider the functional data.
So what's really the benefit of, let's say, the stochastic process and the realization as a functional data compared to the standard, let's say, time series analysis? What's really the benefit? Do we have to tell?
But time series, I consider we can consider time series in functional data, for functional data. It's what I consider in the one of the reference that I show. So it's possible to consider in functional data. Yes. So in this paper, I consider for dependence strong mixing function in time series. This is in time series.
Is it enough, Professor JD? Okay, any other question? No? Oh yeah, please.
Where's the stochastic process in this your situation? Because that's so many assumption in this case, and you can you show for me about the stochastic process? What the what kind of data in stochastic process in this EEG?
About the assumption, if it's a realistic assumption. This is what's a question. If it's the relation between application and if they satisfy the assumption that we consider.
You can put the method in combination in the method in maybe you can use the normal distribution and you can use the data is
But this is the for non-parametric estimation. There are no assumption on the law. This is the difference. I compare a parametric and non-parametric estimation in the second parts. Okay, so it's in the second part. True, that's it. I compared two, and they don't give us the same results. Okay, but with small difference, not very huge, but it's there are difference. And this is what's because in the beginning I started just non-parametric because this is one of the things. No assumptions, but in the stochastic block model, they are allowed that we flow. We suppose some probability, and we suppose that flow some law, some specific law that is known in the literature, a multinomial, and we compare these two methods.
Yeah, two methods is using the stochastic process in each method.
But it's different. The word is not the same because for the first one, stochastic algorithm approximation give us a recursive estimator. But in the second part, in stochastic block model, this is the name of this method is based on the classification that we can see there in this probability. This is the name of stochastic because the blocks can be moved and the dynamically, but here in this part, just the block is based on the probability. If we have the same, suppose the same probability in order to separate exactly the block, each other.
Okay, thank you.
Okay.
Okay, I think the time is up. So thank you very much
Yeah,
for
welcome.
the insightful presentation from Professor Yusri. Let's give him a round of applause.
Thank you. Thank you.
Thank you very much for coming here and give us, yeah, insightful information. And then for the next session is we will have lunch together here, and then at 1 p.m. We will have a class to the international program. So maybe I think it's enough for this session, and enough for me. Thank you very much for your participation and then your questions. I will finish my session today. Wassalamualaikum warahmatullahi wabarakatuh.